Okay, so last time we started for equations. We learned how to solve linear equations and how to solve the quadratic equations. We solve the quadratic equation by factoring, and then we solve, or we can like doing completing the square, or we can use the formula, quadratic formula. So we have three ways to solve quadratic equations. First way is by factoring and equal to 0. Then we find the zeros for the quadratic equations. Second thing is by completing the square. Third way is by the quadratic formula. So let me remind you. So here, equations 1.5. So last time we did the linear equation, and we did. Where's the linear equations? What's the linear equation? How it's look like?
Y equals mx plus b.
Y equal ax plus b, or any equation are equivalent. The equation look like ax plus b equals 0. So any equations are equivalent. Are equivalent to equations of form like ax plus b equals 0. And I give some examples. I explain which of the example is linear equation and which of them are non-linear equation. Then we starting for quadratic equations. Here quadratic equations. We solve the quadratic. The link for the attendance here. So yeah, the quadratic equations, it's an equation of the form ax squared plus bx plus c is any equation of the form ax squared plus bx plus c equals 0. So here in the quadratic equation, we use the ways for by we used the factoring way, then we equal it to the 0. We're using the second way by using it's called the completing the square. But I left here one example. I will do it there. The last thing is by using something is called a quadratic formula. And we talk about also this we use the quadratic formula. Then we talk about discriminant, how to find the discriminant. So let me give you just example before we go to the next. So the last things here we will learn today is called other types of equation. Other types of equation. Okay. Today we're going to learn how to solve other types of equation, but here I left one example for completing the square. Let me do first things the example here I left it for completing the square. Then I'm going to other types of equation. So the example is solve this quadratic equation by completing the square. Solve by completing square. So the example is, last time I did one of them. I did simple example. Today I'm going to do this example, 3x squared minus 12x plus 6 equals 0. How can I solve this one? By the completing the square. So let me remind you the completing square. It says to mix like x squared, if I have something like that, x squared plus bx, I have to add here, look, 1. The coefficient of the x squared is 1 here. So first things, we have to make the coefficient of x squared equal 1, okay? So we have to what? Add b over 2 square for both sides. So for example, if I have something like that equals c, I have to add b over 2 square for both sides. Then I solve this equation by making this equation equal x plus b over 2 square, and this is equal c plus b over 2 everything square. Then we solve this equation. We solve it. Okay. Yes, Angel. Yes, we're taking the greatest common factor to make the coefficient of x squared must be equal 1. You see the one to do these steps. This is the idea. Now, let me go back to the example here. Here we have 3x squared minus 12x plus 6. First things, when we start doing something like that, completing the square, by solving complete the square, first things I have to think how to make this equation look like something like that. So to make this equation look like that, I have to subtract 6 from both sides, first of all. So what I get, when I subtract x6 from both of the sides, I'm gonna get 3x squared minus 12x equal minus 6. Okay, so this is the first step. I make the variables in one side, the numbers in one side. Makes sense? Then here we have 3x squared minus 12x. I have to make it when the coefficient of x squared must be equal 1. Okay? So, for who asked me about the attendant, it's in the chat. Just fill it. So now 3x squared minus 12x equals minus 6. How can we like make the coefficient of x squared equal 1? Or another
Everything
way,
by 3.
we divide everything by 3. But before we dividing everything by 3, there is a way we have to factor this one. We have to factor this one. This is mean I have to make the coefficient of x squared equal 1 by factoring. How can I find the greatest, what is the greatest common factor for these two terms? What is the greatest common factor? Greatest common factor for both of these two terms is a 3. Okay? And what the rest? I open parentheses. I mean like the greatest common factor for the coefficient only. For the coefficient only. Is a 3. And the remaining here, x squared minus 4x equal minus 6. Now look, the coefficient of x squared is 1 now. So it's good. This is what I need. Now, to make these things exactly like this one, I have to divide. Now I have to divide by 1 over, I have to divide by 3, or I have to multiply by 1 over 3 for both sides. Okay? So when I multiply by 1 over 3, I cancel the 3 together. 3 with 3, it's cancelled. It's cancelled. Now what I get? I get x squared minus 4x equal
-2.
negative 2. Somebody asked me, Martin, why you multiplying both sides by 1 over 3? I multiply both sides by 1 over 3 because I want to cancel the 3 in front of the parentheses. Why? Because I need the parentheses look like 1x squared plus bx equals c. C any number, whatever the number is, I don't care. Okay? So when I multiply by both sides 1 over 3, 1 over 3, so I cancel the 3 together. So let me put it in different color. 1 over 3 here, I multiply, and here I multiply 1 over 3 for both sides. Because I want to cancel the 3 and I need it to look like 1x plus bx. So I get now x squared minus 4x equal minus 2. Now I doing the completing the square. So I add b over 2 square for both sides. So what is b here? What is b?
-4.
Negative 4. So I add negative 4 over 2 square for both sides. Makes sense? Is it clear? Negative 2 over negative 4 over 2 is 2, is negative 2. Square is 4. So all this parentheses is actually 4. So we're adding 4 for this term, for this side, and we're adding 4 for this side. Okay? So what I get? X squared minus 4x plus 4 equal minus 2 plus 4 is, what is it? This 2. Okay? This is again 4. 4. Y negative 4 over 2 is 2. My negative 2 square is 4. So we're adding 4 for this side. We add 4 for this side. Now I'm going to complete the square for this side. This is equal x plus b over 2, everything square. X plus, what is 2? B over 2. What is b over 2? It's negative 4 over 2. It's negative 4 over 2, everything square. Equal 2, this 2. Okay? Makes sense? I can write it, yes, I can do it. It's equal, this is here, x, like this is equal x plus minus 4 over 2 square is equal x minus 2 times x plus 4. I can write it. But I'm going to solve it, that's why. I'm going to solve it. It's better to write it like that. Because the question is solving, okay? So now, like I learned last time, if I see something square, I can take the square root for both sides. Last time I gave you property, it said if this is the property. Let me remind you. The property said if I see something like that, x squared equals c, then the solution is x equal the positive square root of c, or x equal minus square root of c. So now look, we have square, x squared equals c. This is like x squared equals c, equal the number 2. So now we're taking the square root for both sides. Okay? We're taking the square root for both sides. Martin, he asked, why we will not write it as x minus 2, x plus 2? It's not, the factor for this one is not x minus 2, x plus 4, x plus 2. The factor for this one here is x minus 2 only square. It's x minus 2 times x minus 2. Okay, Martin? Martin, he asked, why you did not write it as x minus 2 times x plus 2? The factor for x squared minus 4x plus 4 is x minus 2 times x minus 2. And x minus 2 times x minus 2 is x minus 2 everything square. And this is what I get here. X minus 2 everything square. This is look like here x minus 2 because minus 4 over 2 square equal 2. Now I use this property. I take the square root of both sides. Now, taking the square root of both sides, let me go to the next slide. So x minus 2 square equal what? 2. Taking the square root of both sides by using the property, I get x minus 2 equal 2, or x minus 2 equal equal the positive of the square root, or equal minus square root of 2. Now we're solving this. This is like look like linear equation. So what we have to do, we add 2 for both sides because I need x equal. Here I add 2 for both sides. So x equal 2 plus square root of 2, or x equal 2 minus square root of 2. And this is the solution. That's it. Any question? It makes sense how we do the completing the square when the coefficient of x squared is not 1. Okay, if there is no question, let's go to the other types of equations. The last things in this section. Other types of equations. So we're going to solve something like that. It's not linear, it's not a quadratic. Like, let me give you example. We're going to solve something like that. Solve 3 over x minus 2 over x minus 3 equal minus 12 over x squared minus 19. This equation, is it a linear equation? Is this equation is a linear? No, it's not linear. Not linear equation. Is it a quadratic equation, Angel? Also is not a quadratic equation. It's not look like quadratic equations. Not quadratic. So this equation, it's other types of equations. It's not linear, it's not quadratic. The question is, solve this equation. So I give you the idea how to solve equations like that. First idea, it's yes. Angel, he said the least common denominator. Yes. But before we do the least common denominator, we try to move everything, all the fractions in one side, and the other side equals 0. Then, after we're moving everything to one side and make the other side 0, we try to find the least common denominator for all fraction. Let me solve this equation. This example, I mean. The same example, solve 3 over x minus 2 over x minus 3 equal minus 12 over x squared minus 9. So like I said, first step, we move everything in one side. So to move this one to this side, what we have to do?
Add that.
We try to add this guy because it's negative actually. We add it to this side. So what I get? 3. After we adding this one, what I have? 3 over x minus 2 over x minus 3. Here it's negative, so it becomes positive. 12 over x squared minus 9 equals 0. So now we're making all the fraction in one side and the other side equals 0. Now, next step, how to find the least common denominator between x, x minus 3, and x squared minus 9. It's a little bit like I cannot find the least common denominator from the first time. So the things here, the important idea is to combine two together, then I get one fraction plus another fraction equals 0. This goes down, and from this two I get one fraction. Then after that I combine these two fractions, I get one fraction. This is the easiest way I can find the solution, or I can solve this one. Then I make the denominator here a over b, a equals 0. This is the important idea. Then I solve it as a, this one equals 0, because the denominator cannot be 0. If it's 0, this is mean undefined. Okay? So how we can combine the first two fraction here? We have to find the least common denominator between x and x minus 3.
Cross multiply.
Cross multiply, or I can do the x, finding the x least common denominator between these two things. So like he said, I can do a cross multiply. This is true. This is also because the denominator for x and for x minus 3, both of them are like factored already, and they are like simple. Or I can find the least common denominator, then I multiply this fraction by the least common denominator for the other fraction. Okay, let me do step by step here to explain what I said. So the least common denominator between for this fraction, for 3 over x minus 2 over x minus 3. So the factor of x is, what is it? Is x. Why? Because x is factor already. We cannot do factoring for this thing. The factor for the second one, what is it? Of x minus 3, what is it?
X minus 3.
It's x minus 3. Okay, now we multiply this fraction, both of the numerator and denominator, by the factor for x minus 3, by this one. And the second one, we multiply the factor for x, is x, by this. So here we have to multiply by x minus 3. For the second one, we have to multiply by what? By the factor for x, by x. Because nothing canceled here, like we learned like in the previous sections. Nothing canceled. Okay. Now, multiply 3 by this one. Here, look to the denominator, x times x minus 3 and x minus 3 times x. So the denominator become equals. And this is mean we can use the property of property says a over c plus b over c. The denominator are equal. This is mean a plus b over c. So using this property, now the denominator are equal, so we make it one fraction, x times x minus 3 Here we have 3 times this parentheses. They give me 3. We distributed 3 inside the parentheses. What they give me? What is that? Who will help? Angel, you want to solve it?
3x,
3x minus 9.
minus 9, yes.
Okay, for the second one. Here we have minus. Let me make them positive, and then I make it here negative. I transfer the negative from here to the 2. What I get here? Minus what?
2x.
2x. Now the denominator, I keep it like x times x minus 3. I don't have to distribute the x inside. Here what I have to get, 3x minus 2x is
X minus 9.
Is x minus 9. So look, this parentheses is equal as x minus 9 over x times x minus 3. Now, I'm going to find again the least common denominator between this fraction and between this fraction, 12 over x squared minus 9. Okay, let me do it. Now, the least common denominator. Now let me, before like writing least common denominator, I'll write it like what I get. So now I get x minus 9 over x times x minus 3. This is a plus the second fraction here, 12 over x squared minus 9 equal 0. Now this is what I'm going to solve again. Okay, let's do it. Okay, we're going to find the least common denominator between this fraction and the other one.
If we first factor the second part,
Yes.
the squared minus 9.
So who will, okay, this is x minus 9 over what? X minus 9 over what? X, here, what is that?
S minus 3.
X minus 3 plus what here? What is that? 12? 12 over x squared minus 9, I think. X squared minus 9, yes. Equals 0. Now we're going to found again the least common denominator. Least common denominator between these two fractions. So what is the factor for the, so we have to do the factoring for both denominator. What is the factor? The factor for the first fraction, for x,
It's not half.
x minus 3 is the same, like is the same. Now for the second one, what is the factor for the second one? Who will give me the factor for the second one? What is it? Yes, Angel, what is it?
X plus 3, x minus 3.
X minus 3 times x plus 3. So now we doing canceling for the common factor. We have to cancel the common factor. What is, because here we have common factor, but look in the previous one, we don't have common factor, x and x minus 3, x and x minus 3. But here we have a common factor, it's x minus 3 for both sides. So we try to cancel this one by this one. Now we have to multiply the first fraction by The factor
x plus
for this
3.
one, x plus 3, yes, x plus 3.
And the second by
Plus
x.
And the second by x, exactly. By this one. Now, we have the same denominator after we multiply this one by x and we multiply this one by x minus plus 3. This is meaning that both denominator are equal. So what I get now, so here, first one, I get one fraction. The fraction is x squared minus 9 times x. Here we have this one.
S squared
X squared.
minus 3 plus 3x minus 9x plus minus 27.
Okay, again, x squared plus what?
3x
3x
minus 9x
minus 9x
minus 27.
minus 27. Second one plus 12x. Now we simplify it more. This is like polynomial plus polynomial, like we learned it from previous sections. What is the polynomial plus polynomial? I have here x squared. Keep it x squared. We don't have any x squared. I have 3x and 12x plus 15x. No, I have 3x, 9x minus 9x plus 12x. So let me here erase what I have, what I get, I mean. 3
6x negative
plus
6
12
minus 6x.
minus 6x, right? No, plus 6.
Yep, wait.
Because 12 plus
I am
3 minus 9.
will be
So
minus 6 plus 12 plus 6.
So it will be like 6x. Because we have positive 3 plus 12 is 15 minus 9 is 6. Minus 27. This is equal what? 0.
We still can factor there.
Say again.
We still can factor. We can eliminate a value there.
We cannot factor it.
Yes, we can factor.
We can factor it, yes. So look, now again, this 3 fraction, 1 fraction, 2, number 1, number 2, number 3, 3 fraction, we combine it together, we make 1 fraction. See? 1 fraction. This is equal 0. This is what I need. Now, to solve this kind of equation, this is mean we have to make the numerator equal 0. So x squared plus 6x minus 27 equals 0. Now we're solving a quadratic equation. Look, quadratic equation. So how we can solve a quadratic equation? From last time, by factoring or by using the formula. So I'm going to factor it. What is the factor for this one?
Adds plus 9 times adds minus 3.
X plus 9 times x minus 3. Why? Because 9 times minus 3 is minus 27. 9 plus minus 3 is positive 6. Exactly. Now, like we learned from last time for quadratic, I said using this property, if I see something like that, a, b equals 0, this is mean a equals 0 or b equals 0. This is from last class, previous class, last time. So we have here a, this is a, times b equals 0. This means the first one equals 0 or the second one equals 0. So the answer, like Angel said, so x plus 9 equals 0. So we subtract 9 from both sides, x equal minus 9. Or x minus 3 equals 0. So x equal 3. So this is my first answer. This is my second answer. Okay, makes sense? So now the last things for this
But-
equation, we have to
but-
plug these numbers inside the equation to make sure are working or not.
S equals 3 is not a solution because we will be undefined.
Okay, so let me, like he said, Angel is not defined x equal 3. How he know? He plug this one inside the equation here, inside this one. He plug it inside this equation. So let me do it. Any question before moving to next slide? Makes sense how we do that? Okay, let's go now check, is the 3 solution? Is the minus 9 is a solution? Okay, I'm going to do it here, okay, in this area. Now, check. Or no, I'm going to do it in next slide is better. But someone who will give me this formula, okay? So what's the formula? What is the formula? What is the formula? 3 over x plus what? What is the formula? Okay, let me do it by myself. 3 over x minus 2 over x minus 3. This is equal.
Negative 12
No, not equal. Plus
plus 12 over
12.
S squared minus 9.
Equal 0. So we're going to check when x equal 3. This is this when x equal minus 9. And when x equal equal minus 9. So for x equal 3, plug in the formula. So they give me 3 over 3 minus 3 over 3 minus 3 plus 12 over 3 square minus 9. Look here and define the 3. They give me 1 minus 3 over 0 plus 12 over 0. And this is not defined. So here they give me not defined. not defined. So why? Because 3 over 0. So x equal 3, not solution. Now we check for x equal -9. So plug the x equal -9 inside the formula. What I get? 3 over -9 minus 3 minus 3 over -9 minus 3 plus 12 over -9 squared minus 9, and this is will give me solution. I don't have to find it, but this is will give me solution. So the only solution is x minus 3. So the solutions is x equal -9 only. Any question?
No.
Okay. So this is the other kind of solution, other types of equations. Now let me go to another question, another example, another type of equations. So the example now, if I have something like that, 2x equal 1 minus square root of 2 minus x. This is linear. Is it a linear equation? No.
No.
Why? Exactly.
You have a
Why?
square root.
We have square root. So square root is not a linear equation. So is not linear equation. Is it a quadratic?
Yes.
Why yes? We have square. We have a square exponent. To check if it's linear quadratic from the previous slide here, I said a quadratic equation is any equation of the form if I have square or exponents is equal to, this is mean quadratic. If I have exponent equal 1 only, this is linear. If we go back here, we have exponent equal to. Did we have exponent equal to? No, we don't have. This is mean is not also a quadratic equation. It's not a quadratic equation. How we can solve something like that? So to solve something like that, we have to make the root in one side and everything else in one side. So we make the root in one side and everything else in one side. This is mean we have to how we can move this one to the side.
Subtract -1
We
on both
subtract,
sides.
yes. So we subtract -1 from both sides. So
Then we divide by -1, and then we take exponent both sides.
Yes. So we subtract, we get 2x minus 1 equal minus square root of 2 minus x.
We divide by -1 in both sides.
Yeah, we divided by -1 for both sides. What we get? We get 1 minus 2x, because -2 divided by minus, or in different way, let me explain more, or easier way for a student he doesn't know what I did. So here, look, we divided by -1, or we multiply both sides by -1. So multiplying both sides by -1, multiplying this side by -1. Okay, so this is give me -1 times 2x is -2x, -1 times -1 is +1. Negative times -1 become positive, and I get square root of 2 minus x.
And then we square both sides.
Now we're squaring both sides. This is the important idea here. We square these two sides, square this side. Martin, he asked, you're multiplying to make the square root positive, right? Because I'm multiplying by -1 because I need the square root here like positive. I need the sign for the square root positive. Okay, I need in front of the, I need the sign of the square root positive. So now to cancel the square root, I have to square both sides. When I square both sides, I cancel the square root. So what I get after squaring both sides?
We -2x plus 1 all square equals
everything
2
square
minus x.
Plus 2 times 1 times -2x plus the second one square. So what I did here, by using the property says, let me remind you what the property says. A plus b square, this is equal the first part square plus 2 times the first part times the second part plus the second part square. So this is what I did here. The first one square plus 2 times the first times the second one plus the second one square. Now that I cancelled the square roots, what I get? 2 minus x. Now let me simplify it. Minus 2x squared is give me 4x squared plus 2 times 1 times minus 2x, they give me negative 4x plus 1. Now this, we move it equal to minus x. Now we move everything to one side to make equal 0, then we simplify it. I want to move this side, this one, to this side. To move these things to this side, I subtract by 2, then I add x. Okay, so I'm going to do these 2 steps in one time. I'm going to subtract 2 and I'm going to add x. Why? Because I need this side equals 0. So what I get? 4x squared minus 4x plus 1 minus 2 minus x equals 0. I simplify it more. 4x squared minus 4x plus x minus 5x plus 1 minus 2 is minus 1 equals 0.
which one would you prefer to use to factor? Factoring by grouping or completing the square?
So here,
Professor, when you move the x over, doesn't it change sign to positive?
yeah, sure. Yeah, this is wrong. So here, minus x, we added to positive x. Sorry. Yes. So minus 4x plus x, it's become minus 3x. Sorry for that. Here, like that. Now, Angel, what you said?
To end factoring, will you prefer using factoring
So
by
we
grouping or completing the square?
You can like factoring or using the quadratic formula. So I'm going to use the quadratic formula for this one. Okay. So the quadratic formula says
Negative b plus or minus
so
the
x
square
equal,
root of b squared
yes,
minus
negative,
4
yeah,
ac all over 2a.
yes. So let me like write down here. What is my a? Is 4, right? What is b? Second term, coefficient for the second term, minus 3. What is c? It's minus 1. Now let me do it by using the quadratic formula. It says x equal minus b plus negative square root of b square, this square, minus 4 times the first time plus times the third one, 4 times a times c over 2a, 2 times 4. So now the answer is, so now the answer x equal, after you solving this one and you simplify it, it will be like x equal minus 1 over 4 or x equal 1. So just I keep it this for you exercise how to simplify it. So x equal minus 1 over 4, second one x equal 1. This is the two solution. Now, to make sure this solution or this solution work for this equation, you have to plug it again. You have to plug this one inside the equation, you plug the second one inside the equation. But I'm not going to plug it right now. I keep it also exercise for you. You can plug this one inside the equation, you plug the second one inside the equation, and you check which of them solution. I keep it exercise, check x equal 1, and check for x equal minus 1 over 4. Just you plug it inside the equation by in the equation. By plug in the equation, not both in the same time. I mean like everyone separately. Plug inside the equation. Like a previous example. Like example. Okay. Anyone has a question? If you want to go back to to previous slide, this is the how to solve the equation. Makes sense how we do the example like that. Anyone has a question? Okay, if there is no question, I'm going to next section is inequalities. Okay. So now in this section, we learn how to solve equations. Now in next section, we're going to learn how to solve inequalities. And I'm going to define what is the meaning of inequality. Let's go. So here, section 1.8 is inequality. So inequalities definition, I'm going to give you the definition of inequality. But before I write it down, inequality in this section is exactly like equations, like the previous section. But here we're going to use, instead of equal, the symbols equal, less than, greater than, less than or equal, or greater than or equal. It's look like equation, but the difference, instead of equal, we're using different symbols. So inequality is here. Inequality is not it's look like equation but instead of this symbols equal, we going to use this symbol or greater than or less than or equal or greater than or equal. Okay. So this is the difference between inequality and equation. So let me give you example like how is equation, and here we're going to learn how to solve inequality. So example for inequality, something like that, 4x plus 7 less than or equal 19. So this is, first of all, linear inequality. Why? Because as we learn in linear equation, the high exponent here for the variable x is 1. So this is called linear inequality. Is a linear inequality. Why? Because the highest exponent for the variable here is 1. Or, because like I said last time, it's look like close to the form ax plus b equals 0. Okay? Now, how we can solve inequality look like this? So let me starting by doing this one by numbers. Then we're going to learn these things as like by solving the inequality. So the question is now solve this inequality. So to solve this inequality, I'm going to make a table for x plus 7 less than or equal 19, and I'm going to choose x here. No, I'm going to choose x. So I'm going to choose variable x. Then I plug it inside this inequality, and I will check this is right or not. So I'm going to choose x as 1. I choose it as 2, 3, 4, and 5. Now, when I plug the 1 inside this inequality, what is the answer is? When I plug the 1 inside this inequality, what I'm going to get? When I plug the 1 inside this inequality,
11.
what I get?
11. Less than 19.
4 times 1 plus 7 less than or equal 19. What we said, 11, this is equal 11,
Yes.
less than or equal 19. This is true, 11 is less than 19. Is 11 less than 19? Yes. So this is a solution for this linear inequality. So this is the solution. What about number 2? Is it a solution when I plug it inside the equality?
8 plus 7, 15.
Yeah,
Yes,
it's
less
15.
than 19.
What's the answer?
15 is less
15?
than 19.
15 less than or equal 19. This is true. Is 15 less than or equal 19?
Yes.
Yes, this is a solution also for the inequality.
12 plus 7, 19 is equal. Yes, is correct.
What is for 3?
19 equals 19.
19 equal 19. 19 less than or equal 19. This is true. Why? Because 19 less than or equal, we have equal 19. So this is a solution also for this inequality. So this is true here. What about 4?
It's not a solution. It's greater than 19.
What's the answer? 4 times 4,
16 plus
16,
7
plus
will be
7 is
23.
23. So 23 less than or equal 19. Is that true? Is 23 is less than or equal 19?
No.
No, it's not a solution. So this is not a solution for this inequality. So here x. What about the last one, 5? When I plug the 5, it's give me 20 plus 7 is 27. Less than or equal 19. Is it 27 less than or equal 19?
No.
No, it's not. So this is not a solution. So all the solution is from 3, and all the solution are any number less than or equal 3. This is mean 3, 2, 1, and all the negative numbers. 3, 2, 1, all the negative numbers. If I plug it inside this inequality, it will be true. So the solution will be from 3 and down. Any number from 4 and greater than 4, it will not be a solution for this inequality. So here I can write down the solution. All the numbers x such that x less than or equal 3. Any numbers less than 3 or equal to 3 will be a solution. So here look the difference between inequality and equation. There we have one solution, but here we have infinity many solutions. We have 3 solutions, 2 solutions, 1 solution, 0 solution. But there in equation we have only a solution only one solution. So here is the difference between inequality and equation. In equality we have infinity solutions, but in equation we have one only solution. Make sense? Now let me go over, and also here I can like make the solution as a graph. How can I graph the solution? So I can make a line. I'll show you how to do it. To be like a line. Here's a line. All the numbers less than 3 is a solution for this inequality. So here we have 0, 1, 2, 3. Here we have -1, -2. So any numbers less than 3 from 3 and goes down will be a solution. Okay? This is the graph for solutions. Any number from 3 and down will be a solution. Make sense? Now let's go to how to solve linear equation by using, before we go to the linear equation, I'm going to give you the rules of inequality. From these rules, we're going to start how to solve linear equations or solving any non-linear equations. Okay, so rules of inequality. So first rule says if I have inequality look like this, A less than B. This will be if I add this less than or equal. If I add the same quantity to the both sides of this inequality, I'm going to get equivalent inequality to this one. Okay? Like equation. If I add A plus C less than or equal B plus C, and this is equivalent to this one. Both of them are equivalent. So adding the same quantity to the both sides of the inequality, they give me another equivalent inequality. Second one, if I subtract the same quantity, they give me the same things, another equivalent inequality. A minus C less than or equal B minus C. So subtracting the same quantity for both sides, they give me the same equivalent quantity inequality for this one. Third one, if I have positive numbers This is a positive number, and I multiply to the both side of the inequality. They give me another inequality are equivalent to the first one. Then A less than or equal B. This is give me another inequality such that A times C is the same as greater than or B times C. Adding, subtracting, multiplying. But look, the number must be positive. The number here, C, must be positive. What if the number is negative? If C is negative, then A less than B or equivalent to another inequality, but here the sign for less than, we reverse it to greater than or equal. This is the difference. A times C greater than B times C. If the number is negative. Okay, number 5. If A is greater than 0 and B greater than 0, then I have to know A less than B or equal, equivalent. If I want to flip this one, I have to also to change the inequality sign symbols. 1 over A is greater than 1 over B. We have to change the symbols. Look, greater here, less than. But both of the A and B are positive. Number 6, if A is positive, sorry, not A is, if A less than B, and C less than D, I have two inequality. Then if I want to add this inequality to this one, they give me the same sign, less than or equal B plus D. The last one, if A less than or equal B and B less than or equal C, I can do the transitive, then A less than or equal C. By the way, this name here, transitive, here adding two quantity, here adding two quantity together. We add A to C, we add B to D. Okay, we're going to stop until here today. Anyone has a question? Before we stop here, anyone has a question for these rules? Okay,